All right, following up arithmetic sequences where we're just finding the terms of some pattern where we're either adding or subtracting the same value every time, kind of like a linear equation. Arithmetic series is where we're going to take those terms from an arithmetic sequence and add them up. So we could always go through and for an arithmetic sequence, find every term, add all those terms up. Not so bad if it's a small number of terms, but if it's a large number of terms, we're going to want to use this formula. So the sum of the first n terms of an arithmetic series is the product of the number of terms and the average of its first and last terms. Taking a look at this example here, if the arithmetic sequence that we had was 2, 4, 6, 8, 10, that one we looked at a little bit ago. So the series would be 2 plus 4 plus 6 plus 8 plus 10. Again, not the worst option to do by hand. You could just go through and add them all up, which is great. The pattern that we're using here is 5, that's your number of terms. The 2 is your first term. The 10 is your last term, divided by 2. So we have 5, the number of terms. 2 plus 10 is 12, divided by 2 gives us 6. Looking at the generic version of this equation, we got S sub n. S sub n means the sum of the first n terms of that sequence is n, again, your number of terms. A sub 1, your first term, plus A sub n, your last term. They often refer to it as your nth term. I'm also going to say your last term, divided by 2. So again, kind of that arithmetic average between your first and last terms. Taking a look at a specific example, it says find the indicated sum for the arithmetic series, and I threw this summation notation back at you. That's okay. What we're looking for here, we got S sub n equals n times A sub 1 plus A sub n divided by 2. Let's see if we can translate this summation notation into this arithmetic series. So we've got k equals 1 up to k equals 12. That means we're adding up 12 total terms. So n is 12 terms. Our first term that we need to find is a sub 1. A sub 1, we're just going to plug in 1 for k. We got 15 minus 4 times 1, which gives us a grand total of, well, 15 times 4. Sorry, 15 minus 4, goodness gracious, is 11. The last term in the sequence, we're finding 12 terms. We're going to go up to that 12th term. So we got a sub 12 equals 15 minus 4 times 12. We got 15 minus 48, giving us a grand total of negative 33. Now we have enough to plug in what we need to know. We got S sub 12. We're adding up the first 12 terms of the sequence. Equals 12 times first term we found was 11, plus last term we found out was negative 33. Divide that by 2. Let me keep this going down here. We got 12 times 11 plus negative 33 is negative 22 divided by 2. So we got negative 22 divided by 2 is negative 11. Well, 12 times positive 11 is 132. I almost misspoke there. So 12 times negative 11 is negative 132. So we'll say S sub 12. The sum of the first 12 terms of this arithmetic series is negative 132.